Okay, in this trig identity, we have an exponent of 4. We haven't really seen this yet. As always, I don't know where to start, other than as a rule of thumb with the more complicated side, which in this case, I think there's no arguing that it is going to be the left-hand side. So let's start over here. Left side equals, and I'll just copy it out. And for sake of brevity, I'm going to start, I'm going to drop the x here. Okay, we all know that the argument is x. I really don't care to write that over and over again. So I'm just going to focus on kind of the form. Cos squared minus cos to the 4. Again, this is just shorthand. Maybe on a test, if you have a teacher who's a real stickler for notation, definitely write in the variable, but you really don't have to when you're doing it. Okay. Once again, I have no idea where to begin, but I have a little inkling that I think I want to combine the sine 4 and cosine 4 together, plus 2 cos squared. And the reason behind that thinking is because, I don't know if you remember, but a difference of squares can be factored. And I don't know why I'm doing this other than, actually I know why I'm doing this. I want to bring down the power of 4. Okay, difference of squares can be factored as x minus y and x plus y. And remember, any even power as a difference can be also factored. I mean, if you think of x to the 4 minus y to the 4, that's the same as x squared squared minus y squared squared, which is equal to x squared minus y squared times x squared plus y squared. And that is the idea that I'm going to use for these two guys over here. Okay, it is a difference of powers of 4, so to speak. So let me just maybe minimize this a little bit, shrink it, and just put this idea, let's put it over here. So what I'm going to get is sine squared minus cos squared in brackets times sine squared plus cos squared plus 2 cos squared. And again, the motivating idea here was to try to reduce, I want to reduce the exponent 4 to a power of 2, or ultimately, nothing, 1 or something. But this is promising, because if you haven't noticed already, in here, sine squared plus cos squared, you might recognize that that is the Pythagorean identity, and I can just replace that with 1. Or 1 times sine squared minus cos squared, which is just going to be sine squared minus cos squared, plus 2 cos squared. Aha. I already see the end. It is in sight, because these two guys here, they are like terms in quotes. I can combine them together, and I get sine squared plus cos squared. And once again, the Pythagorean identity equals 1, which equals the right side, and that completes the proof. So give this a try. Hopefully you understood what I did here. I would recommend trying to prove this another way. Remember, there is no one standard way in proving an identity. A nice proof is one that uses the fewest possible steps. And this is just one, but I do feel like there is another. So if you want to test yourself, give that a try.